Good morning, everyone. Hope you're having a good start to your day. Sorry I'm not here with you. Had a meeting today about the regional tournament that we're going to be hosting starting Friday night and into next week. So, again, I'll be back with you tomorrow. Um, it was honestly a pretty good day to miss. We don't have any homework from the night before to go over. We're starting a new unit, and in all seriousness, what we're doing with these today, I think you're going to be able to handle really well. We're talking about matrices, and you have this paper at this point, hopefully. If not, it's coming your way. You also need a calculator today, so go ahead and grab one if you didn't already. And when we get to the point where we're using our calculator, you won't have to get up at that point. You'll be able to just work right into it. So we're talking about matrices. And a matrix, as you can tell, is made up of just a bunch of numbers that are organized in some grouping symbols that we call brackets. So what we do is those matrices are really, the purpose was to organize numbers. And again, those numbers can belong to a variety of different things. So matrices can be used in order to organize numbers for a variety of different types of mathematical problems, mathematical issues. So let's work through this, and I think you guys are going to have no problem with it. And then, of course, you'll have some time, hopefully, at the end of class to work through your assignment. Tomorrow I'll be back, and we'll go over any questions that you have. And if you're doing great, we'll move right along. If not, then we'll clean some stuff up on Thursday. So, matrix. A matrix is a rectangular array of variables or constants in rows or columns usually enclosed in brackets. As you can see, that's exactly what we have over to the left. Okay, we got some rows and we got some columns of constants, numbers that have no variables, and they're enclosed here, as you can see in these brackets. Now, the elements are the individual values within the matrix. Okay, so when I talk about the elements of a matrix, I'm talking about -3. That is an element of this matrix. -15, that is an element within this matrix. So element A sub xy, okay? Again, those are subscripts, so they're smaller than the A. So element A sub xy is used to denote each element where x is the row number and y is the column number. All right, so for example, if I wanted you to take this matrix that we have here, and I want you to describe what element is being listed by A sub 2, 5, and A sub 3, 1, and A sub 1, 2, and A sub 3, 4. That's not A sub 25, okay? The way that this is written, it's A sub 2, 5. So when I look at this and I say, all right, this is row 1, this is row 2, and this is row 3, and then I look at my columns, and this would be row or column 1, column 2, column 3, column 4, and column 5. So what I'm doing is when I'm specifying a certain element, I am going to row 2, column 5, and that's the value that's located in that position. So A sub 2, 5 equals -2. Okay? A sub 2, 5 is -2. So that's not too hard, right? So let's do a couple of those together. If I say A sub 3, 1, again, that's my third row. That's my first column. So we're talking about the value 5. So A sub 3, 1 has a value of 5. All right? Pretty easy stuff, right? So if I'm talking about how to identify the specific element of a matrix, you're going to see it written in this form where you have your element listed as A with a subscript representing the row and the column. So one more I'm going to do with you, and then hopefully you'll answer a couple for me. A sub 1, 2. So that's row 1, that's column 2, so that's the value 40. So A sub 1, 2 equals 40. All right, now you guys take over for a second. I want you to, real quick, try to find A sub 3, 4, A sub 1, 5, and A sub 2, 2. And I'm going to give you, in this video, about 30 seconds to go find those. Okay, so hopefully you've had time to do that. What was A sub 3, 4? A sub 3, 4 was 52. Hopefully you got that one. The next one, A sub 1, 5, first row, fifth column, was 21. And A sub 2, 2, that would be second row, second column, so that would be 32. So if I'm trying to specify the location of any of these values in our matrix, we're going to start with the row, and then we're going to go next to the column. So very simple way of denoting where each element is located in a matrix, okay? All right, so let's talk about this next part, which is how do we identify the dimensions of a matrix? A matrix with, and we'll say M rows and N columns is said to be an M by N matrix. So clearly, we're going to start with how many rows there are. All right, so if you look at this one, how many rows do I have? How many horizontal rows are listed here? Well, that's just one. So this is going to be a 1 by, and how many columns? Well, I know it's just one number, but that's 1, 2, 3 columns. So this is a 1 by 3 matrix. A 1 by 3 matrix. Okay, let's do the next one. Again, rows first. So 1, 2, 3, 4 rows. So 4 by, and then 1, 2 columns. So this is a 4 by 2 matrix. Okay, take, again, about 30 seconds and figure out what is the dimensions of this matrix and this one, both. Okay, hopefully on number 9, you've already done that. There are 3 rows and there are 4 columns, so that's 3 by 4. So always do rows first and then columns. And number 10 has 2 rows and 6 columns. So when we describe the size of a matrix, we're always going to go rows by columns, okay? Now that's going to come in important here as we move into tomorrow or Friday, depending on when we get there. When we talk about multiplying matrices, it's very important to know the dimensions and understand how those dimensions work. So if we talk about equal matrices are 2 matrices in which each element in one matrix is equal to the corresponding element in another. Now, I know that's kind of a no-brainer, but anyways, that doesn't happen very often that we have two equal matrices, but that's what has to be the case. They have to have every element that corresponds with the other matrix has to be identical. Now, when we talk about the different types of matrices, you've got row matrix. A row matrix, of course, just has a single row. So you might have an A, B, C, kind of like number 7 up there. That's a row matrix. You have a column matrix, which would only have a single column, like X, Y, Z. We haven't seen one of those yet. We've only seen the row column. You obviously have square columns, which actually looking at all the examples that we haven't had a square column or a square matrix. A square matrix just means it has the same numbers of rows as it has columns. Of course, those values could be anything. To make it a square matrix, it just has to have the same number of rows as it has columns, like this one does, a 2 by 2. And then a zero matrix, and this is kind of a silly one, but a zero matrix is when every single value in that matrix is a 0. And there is actually a purpose to that. But we're actually not even going to cover that in this class. So we won't even talk really about zero matrices moving forward. But these are your special matrices. You've got row matrix, column matrix, and square matrix, which we're actually going to discuss a little bit. But then you have a zero matrix, which we probably will not. All right, let's move over to the back, and let's look at some actual operations. Now, I told you that tomorrow we are going to multiply, and that might seem weird because we're going to multiply today too, but we're not multiplying matrices. We're doing what we call scalar multiplication. There's a difference, and I'll explain that, okay? So, for sure, when we deal with matrices, they can be added or subtracted, but only if they have the same dimensions. So I wouldn't be able to take this 3 by 2 and add it to this 2 by 3. They're not the same dimensions. Now, could I take this 3 by 2 and add it to this Z? For sure, look, they're the same dimensions. When they're the same dimensions, we're allowed to add and subtract. Same with X and Y. Look, they're both 2 by 1, 2, 3. They're both 2 by 3. I could add them, I could subtract them. In order to add and subtract, our matrices have to be the exact same dimensions. Okay, that's not true about multiplying, and we'll talk about that tomorrow. But anyways, let's take X plus Y. Now, it's very, very simple. Okay, don't overthink this. But I want to tell you this right off the bat so you know exactly what kind of matrix to draw. If I'm adding a 2 by 3 with a 2 by 3, guess what the result will be? It will be a 2 by 3 as well. So I can go ahead and write the size of my matrix down. And all we have to do is take our same elements and combine them. When I add these, because see, it's adding. When I add these, I'm going 24 plus negative 15. So I'm going 24 minus 15, which is 9. I'm going negative 8 plus 29. Or in my brain, I go 29 minus 8. That's 21. I go negative 3 plus 17, or 17 minus 3. That's 14. Negative 4 plus 9, or 9 minus 4, that's 5. 6 minus 5 is 1. And negative 17 plus negative 2, or negative 17 minus 2, is negative 19. Okay? Now, in my opinion, these are too easy to do calculator work with, in my opinion. Now, I do want to show you guys calculators today. I want you to see how you can enter these because, again, if a calculator is at your disposal, which it is when we're in class, it is when you take big tests for this class. So I do want to show you this one. I don't want to show you all of them because I just think it's too easy. So let's go to our calculator real quick. We're going to use it a little bit today, and we're going to do a little bit of adding and subtracting with matrices. So let's start with x plus y, okay? There's a couple ways of going about this. You could name matrices and then do different operations with it. I'm not going to do that. I'm going to use alpha zoom, and remember, this is a 2 by 3 matrix. So I want you to go in here and I want you to change it to a 2 by 3 matrix. And you'll know you changed it correctly because it'll have all the parts that you need. So then plug in x, because that was the first one. So we have 24, scroll over, -8, scroll over, -3, keep scrolling over, it'll go down, -4, over to 6, and over to -17. Then come outside this matrix and push plus. And we're going to do another one. So I'll do alpha zoom. I already have it set for a 2 by 3, so I can just push enter. And I can put in my y matrix, which is -15, scroll over, 29, scroll over, 17, scroll over, 9, -5, and -2. And when I push enter, sure enough, it gave me every value that we had on our paper. 9, 21, 14, 5, 1, -19. Identical. Okay, it matches perfectly. So here's the deal. In my opinion, typing all that in, it took longer than me just doing it in my head. Now, I understand that sometimes we do rely a lot on calculators, and I don't want to tell you, don't do that. But I also think that using your brain sometimes is really good. So with that being said, that is accessible to you. If you remember how we plugged that in, you can do this with any matrix. So alpha zoom will pull up my matrix where I can put in the size, my dimensions, and then I can do the work. We'll do one more, okay? So let's change this now to a 3 by 2, because that's what the other ones are. And they're wanting me to do z minus w. And those are both 3 by 2s. So I can do this. So let's pull up a 3 by 2. And let's plug in, let's go back to my paper real quick. Let's plug in z. Okay, let's plug in z. So I'm going to go back here and plug in z, which is -3, -2, next row, -16, 0, just keep on going, 12, and 9. And then we're going to subtract, and then we open up another one, so alpha zoom, it's already ready, 3 by 2, and we plug in w. That's -1, 9, -11, 15, 8, and -20. So the only thing that's hard about this is just the tediousness of actually typing them in. But when it spits out your answer, you can go straight to your paper and you can write this matrix. -2, -11, -5, -15, and then 4 and 29. And there you have it. Matrix is done. Now, if I did this in my head, I would have went like this. -3 minus -1. Well, -3 minus negative is +1. -3 plus 1 is -2. I would have went -2 minus 9. Because remember, we're subtracting. So -2 minus 9 is -11. I would have went -16 minus -11. Minus negative turns to plus, so that's -16 plus 11, or 11 minus 16, -5. 0 minus 15, negative 15, 12 minus 8, 4, and 9 minus negative 20, so plus 20. 9 plus 20, 29. See, I could have done that in my head so fast. So I would encourage you guys, to do that. Now look at this one. This one wants to take W and add X. Now if you went to your calculator and you tried to do that, you're going to plug all that in just to see that it's not possible. Okay? Remember, when it comes to adding and subtracting, you only can add and subtract matrices that have the exact same dimensions. So please remember this. So are we allowed to go X minus Y? Yes, they're both 2 by 3s. So we're going to have a 2 by 3 matrix at the end. And I'm going to do this one in my head. Feel free to go to your calculator. So I'm going to go order 24X minus negative 15. Well, minus a negative is plus. So 24 plus 15 is 39. Next, negative 8 minus 29. Negative 8 minus 29 is negative 37. Then I'm going to do negative 3 minus 17, negative 20. There's my top row. Now my bottom row, negative 4 minus 9, negative 13. 6 minus negative 5. Well, minus negatives plus 5, so 6 plus 5, 11. And negative 17 minus negative 2, or plus 2. Negative 17 plus 2 is negative 15. Now, if you did that on your calculator, you should have gotten the exact same answer as me. If you didn't, you may have left out one of those signs. Remember, make sure you put these in as negatives and not minuses, okay? There's a big difference in our calculator between using this button here. If you see my cursor wiggling, there's a big difference in using this number here to represent a negative number and using this to represent a minus. Make sure you use negatives when you're dealing with your numbers, okay? So there you have it. That's how we add and subtract, okay? Now, I told you that tomorrow we will be multiplying matrices. And now I'm not like saying we're not multiplying with matrices today, but tomorrow we're actually going to do what we just did with adding and subtracting, where I take a matrix and multiply it by another matrix. Today, we're going to do what we call scalar multiplication. Scalar multiplication is not multiplying matrices. It's multiplying a matrix by a number. So for example, if you look right here, and I got to kind of stay zoomed out a little bit, if you look at 3 times x, what that's wanting you to do is it's wanting you to take your x matrix right here and scale it up by multiplying every single element by the value 3. So does that change how big the matrix is? No, it's still going to be a 2 by 3. What it's going to change is I'm going to multiply every one of those elements to find what those proportional values would be 3 times bigger. So I'm going to go 24 times 3, that's 72. I'm going to take negative 8 and multiply by 3, negative 24. I'll take negative 3 and multiply by 3, negative 9. I'll take negative 4 and multiply by 3, negative 12. I'll take positive 6 and multiply by 3, 18. And finally, I'll take negative 17 and multiply by 3. Might need to use your calculator for that one. That's negative 51. Now, I want to just keep showing you this. Let's say we hate working with fractions. Well, I could have done that with this one too, but multiplying by 3 for most of you guys is very simple. And I know that. And if you want to do that, then please do that. But let's say you hate 3/4. You don't want to multiply by 3/4. I get it. Well, that's where we could go to our calculator and we could do 3/4 times the matrix W. Now, if you look at W, it's a 3 by 2 matrix. So I'm going to go ahead and write that I'm going to have a 3 by 2 matrix when this is all said and done. But because I don't like working with fractions as much, I'm going to go ahead and do this one with my calculator. Now, let me just kind of clear this off a little bit. We've got a little mess. So I'm going to do my alpha y equals, and I'm going to plug in number 1, 3/4. But then I'm going to pull up my matrix. So I'm going to do alpha zoom. And remember, these were 3x2s, which is actually what I did last. So it's already set, 3x2. So I'm going to push OK. Now I'm going to throw my W in there. That's -1, 9, -11, 15, 8, and -20. So in a problem like this, where the values are not quite as appealing as multiplying by 3, feel free to use this. And sure enough, they're not beautiful answers, but here they are. It's -3/4. Then you got 27/4. You got -33/4. You got 45/4. You got 6 and -15. Now let's say you hate seeing the answers like this. You can also take this matrix, go up there, and like I did, scroll up, pick it. Actually, you don't even need doing that. Hang on, we're going to just, it's going to take the answer, and I'm going to do alpha y equals, and I'm going to change this to decimals. And let's say I don't like seeing it like this, -3/4 and 27/4, and I wanted to change that whole thing to decimals. There it is. -3/4 is C, -0.75. 27/4 is 6.75. So if you like the look of these decimals better, feel free to change this to a decimal. We could have also done that if we'd have changed 3/4 to 0.75 right off the bat. But anyways, we didn't, and that's what we came up with. So here's my answers in case you didn't have a chance to write those down. And let's keep on going. So here is the first time where I'd say you probably could save a little bit of time going straight to your calculator. Now, first of all, am I allowed to take -5x and add it to plus 2y? Well, yeah, because x and y are both 2x3 matrices, so we're going to be able to scale them and add them. Let's see if the same is true for w and z. W and z are both the 3x2s, so I can scale them and subtract them, no problem. And again, I would probably recommend once you get to this big of a problem, maybe go spend a little bit of time with the calculator. Now, I'm going to do this on number 17 in my head with my hands. And you go to your calculator if you'd like, and we'll see if we can race who wins. So I'm going to scale x, that's this one right here, a 2x3. I'm going to scale it by multiplying by -5. I ain't going to move too fast because I don't want you to, I don't want to beat you too bad. All right, so I'm multiplying everything by -5. So here I go. 24 times -5 is -120. And -8 times -5, +40. Then you've got -3 times -5, that's +15. Now at this moment, I bet you're thinking, yeah, but the chance of messing up is a lot less using a calculator. You're probably right. It's probably wise. If you're not great with multiplication and adding, it's probably smart to go ahead and use your calculator. But I'm going to go ahead and scale these and then add them. Keep going with my brain. So -5 times -4 is +20. And -5 times 6 is -30. And finally, -5 times -17 is +85. Now I'm going to scale y by multiplying all the values by 2. So 2 times -15, -30. 2 times 29, that's 58. 2 times 17, that's 34. 2 times 9, 18. 2 times negative 5, negative 10. And 2 times negative 2, negative 4. Okay, now, I'm going to now take those and add them. I've scaled them, now I'm adding them. So I'm adding the like elements. So negative 120 plus negative 30 is negative 150. 40 plus 58 is 98. 15 plus 34 is 49. 20 plus 18, 38. Negative 30 plus negative 10, negative 40. And finally, 85 plus negative 4, or 85 minus 4, 81. Now, some of you guys probably use your calculator, and you may have beat me. And that's great. As long as you know how you're using your calculator to get these right, I'm fine with you using them. In fact, I don't want to fight it. Let's go ahead and do the rest of these problems using our calculators. So let's do 4w minus z. All right, so I'm going to go up here and look at this while I go to my calculator and do 4w. So 4 times alpha zoom. What is w? Well, it's a 3 by 2, which is what this is set for. So let's plug it in. We got negative 1, 9, negative 11, 15, 8, and negative 20. Now come outside of this, and the rest of the problem, go back and look at it, says minus z. So we're going to subtract z, alpha, zoom. Obviously z is another 3 by 2. So I'm going to plug it in. You got negative 3, negative 2, negative 16, 0, so just go on by, 12, and 9. And the beauty is, when you push equals, it will do all the work correctly for you, and your answer for 4w minus z will be, let me write it down, negative 1, 38, negative 28, 60, 20, and negative 89. So I hope that you understand how to utilize that calculator to do adding and subtracting and also scalar multiplication with your calculator. Now again, this one, if you're going to use your calculator, guys, you're going to do exactly what it shows. If you're going to do this with your brain, you're going to add w and z first and then scale it by multiplying by negative 3. Same here. You're going to do y minus x first and then scale it by multiplying by 1/2. But if you're using your calculator, you can go straight to there and go negative 3, open parenthesis, and then you can pull up your w plus z. Well, again, w and z are both 3 by 2s, so I'm going to go alpha, zoom, do a 3 by 2, plug in w, negative 1, 9, negative 11, 15, 8, and negative 20. And then still within those parentheses, you're going to add to that, because it was negative 3 times w plus z. You're going to add to that your next matrix. Again, another 3 by 2. And z is negative 3, negative 2, negative 16, 0, keep going by, 12, and 9. And your calculator will do all the work. I'm going to close out the parentheses, so it's going to do the adding first, and then it's going to scale everything by multiplying by negative 3. So my answer for this one here is another 3 by 2, and it is 12, negative 21, 81, negative 45, negative 60, and 33. So again, that's how you do this, okay? It's pretty simple. If you want to go type in number 20 in your calculator, you can. Just for sake of time, I'm looking at this video. It's 35 minutes long. I'd like to give you the last 10 minutes to work on this assignment. If it hasn't been handed out yet, it's coming your way. I know a lot of this is calculator work when you get down here to these problems. Desmos is okay with matrices. You can play around with it. It does all the stuff. It might be a little harder for you to find. You got to go into your functions, that FUNCS. It says funcs, I think, on your app if you have that Desmos app. And you can do all these same matrix operations with your calculator on your phone. But I wanted you to see how we do it with our calculator here because that's the one you can use on a test. So anyways, go ahead and work on this assignment. We'll discuss it tomorrow, see how you feel about it. If you feel great, we'll move on. If not, we'll talk through it a little bit more. But again, hope you have a great rest of the day. We'll see you tomorrow.